Good afternoon, everyone. So today we are going to discuss mock test 2, and since obviously it's a mock test, that means it is exactly on the same pattern as the actual exam. So obviously first 10 questions are of 2 marks, next 12, that is 5 marks, and last 2 obviously 10 marks each. Right? So without further ado, let's begin with the first question. Now, he says the product of 7 and the 6-digit number A, B, C, D, E, F. So he is talking about product of 2 quantities. One quantity is 7, right? And the other quantity is 6-digit number A, B, C, D, E, F. 7 into A, B, C, D, E, F. Right? So obviously I can see this is the first digit, second, third, fourth, fifth, sixth. Or if you want to start from here, same thing. Now he says this product, and listen to this, is actually equal to the product of 6 and the 6-digit number DEFABC, right? So this product is again actually equal to product of 2 quantities. First one is what? 6 into, now the second 6-digit number, that is DEFABC, right? You can see this is a 6-digit number. Now he says if this is the case, then write the sum of the digits of the smaller of the 2 6-digit numbers. Now, which 2 6-digit numbers is he talking about? First one is this and second one is this. He says you need to write the sum of the digits of the smaller of the 2. So you need to determine which is the smaller one. Now, I can say which is the smaller one provided I know the number, provided I know the number. So basically, all I need to do is find out the value of A, B, now, maybe I can find the value individually, or as a chunk, maybe I can get the value, right? So I have this condition. Using this condition, I need to proceed further. Now, product of 2 quantities. Now you will say, ma'am, just multiply the 2. Now the thing is, since I don't know these digits, it will be difficult to multiply 7 with this, right? If I want to multiply the number, how can I proceed when I don't know the digits? I can go for the expanded form. Now, you can say, ma'am, you can write this number in the expanded form as A into 10 raised to power 5 plus B into 10 raised to power 4 plus C into 10 raised to power 3 plus D into 10 square plus E into 10 raised to power 1 plus F. Right? This is the expanded form of this one. Mind it, I can do this the same thing on the right hand side as well. But is there a better way to write the expanded form? Mind it, just look at the 2 numbers. First number is obviously this one, second one is this. Now you can see that this is a chunk of the number, this is the chunk of the number, right? Chunk, chunk. As you can see, ABC is present in both of these. So ABC as a unit is present in both of these, and I'm not interchanging any of these numbers. So rather than writing the expanded form like this, what I'll do is, I will make use of this fact that I have ABC over here, I have ABC over here. I will write the expanded form as ABC, I will not touch it because it's already there. ABC into, obviously that is 10 cube, plus DEF, again I will not change it because I need that chunk, so DEF, right? I will multiply 7 with this. I will write the expanded form of this number in this way. Cool. On the similar lines I can do on the right hand side, so 6 into, now this becomes DEF into 10 cube plus 8. Right? Now mind it, I can write it 7 into 1000 into ABC. Now ABC, DF, it is occurring again and again. What I can do is I can just replace it or substitute it. So let ABC be X and DDF be Y. So that it is a bit easier for me to see it. Now obviously I can see that X is a 3-digit number and Y is a 3-digit number. Right? So this becomes 7 into, this is nothing but 1000X. Plus Y is equal to 6 into, this becomes 1000Y plus X, right? I will obviously combine the like terms and ultimately I will get 538X equal to 461Y, right? This is a prime number. This can be written as 2 into 269. 269 is again a prime number, right? Now, I need to solve this equation. I need to find the value of X and Y. Because if I know X and Y, basically I know this 3-digit number, I know this 3-digit number. So that means I know the number. Now mind it, I know that 461 is a prime number. 461 will not divide this one. Cool? Right. So that means 461 must divide X. Now 461 must divide x. That means either x can be 461 or its multiple. Now I know that 461 is a I know that x is a 3-digit number, right? So there are hardly any possibilities. First possibility I'll take when 461 divides x. So that means let me take x as 461. Right? On similar lines, obviously 538 will not divide 461. It has to divide x. It has to divide y. Right? Again, y is a 3-digit number. That means hardly any possibility. In fact, just one possibility. That means y has to be 538. No other possibility is there in fact. Right? So my numbers actually are nothing but one number is 461 and 538. Right? Second number is 538 and 461. Right? My 6-digit number. Now, which is the smaller of the two? Obviously, this one. Right? You can just add 3 digits and you will get the answer as 27, which is the correct answer. Alright. On to the next one. Now, he says ABCD is a trapezium. So, let me have my screen. But, before that, AD being at right angle to AB and AD is actually perpendicular to AB as well as DC. So I will make the trapezium accordingly. So suppose my trapezium looks like this. Alright, so this is A, B, C, D. Right, now he says that AD is 10, so this length is 10. DC is 8, so this length is 8. Now he says, and diagonals BD and AC cut at 90 degrees. Alright, so diagonals cut at 90 degrees. Right, so this angle is 90. Okay. And again, I'll mark this 90, this 90. Since it's a geometry question, I would advise please write all of these things in your diagram. Right? Now he says write the value of 2 by 5 into area of ABCD, which is trapezium. That means indirectly I need to find the area of trapezium. Now I know that area of trapezium is nothing but half into height into sum of parallel sides. Right? Now let's see what do I know. Do I know height of the trapezium? Answer is yes. Because I already know this length, which will be the height of the trapezium, which is 10. Into sum of parallel sides. Obviously, this and this are parallel, right? 90, 90. Now, that means I want this plus this. This plus this one, so already I know this one, which is 8. Plus, now the other parallel side is 8. That means I can find the area of trapezium provided I know this length 8. Right? I'm interested in this now. I'm interested in the length of a triangle. Now the thing is, how do I get this length? Mind it, I have to make use of the fact that it is a trapezium. That this is 90, this is 90. Also till now, I have not touched the fact that this is 90 degrees. Diagonals intersect at 90 degrees. Now, in how many different ways can I use 90 degrees? First thing that comes to my mind, that is Pythagoras theorem. Right? This is also 90 degrees. I'm interested in this. But for that, I need to know this length. Right? Let us be O. I need to know AO. I need to know BO. Right? It will be difficult to get these lengths as such because all I know is that 10 and 8. Right? Okay. So maybe Pythagoras theorem is not being applied over here. So what else can I use 90 degree for? Now, side of the triangle. Maybe I can find some congruent triangles. But the thing is, I don't think I can find congruent triangles over here. Right? What kind of triangles can I actually find? If congruent triangles are not there, maybe similar triangles are there. Right? We know the ratios are fine. Now, let me find these similar triangles. Mind it, since I need to find AB, I should look for the triangles where AB is the side. Right? So, I can have ABD. ABD. Right? Let me consider this triangle. Right? First of all, AB is involved. Secondly, 90 degrees involved. Right? So many 90 degree right angle triangles are there, right? So obviously I will choose a right angle triangle because I need to go for similar triangles. So let me consider triangle ABD. I'm not writing the corresponding parts, I'm just considering it. And the second triangle that I can consider. Now I know AD, I know DC, right? Both of these lengths I need to accommodate. So that means maybe I can use this triangle ABC. Right? So I've considered this one and I've considered this one. Let me say whether these two triangles are similar or not. Obviously, this is 90, this is 90. One angle is fine. Now, the second angle I need to correspond. Now, how do I go to the second angle? Alright, let me start from somewhere. So in this triangle, let me start with this angle. Let this be theta. Right? Mind that this is theta, this is 90, this is 90 minus theta. The entire is 90, this is 90 minus theta, that means this is theta. That means theta is present in this triangle and theta is present in this triangle. So that means this triangle is actually similar to this one. Right? Two angles are equal. So let me write the corresponding parts now. So triangle ABD is similar to triangle. Now corresponding to A, I will have B. Corresponding to B, I will have A. So DAC. Done? Let me write the corresponding parts. Obviously, I need AB, so let me write AB by DA. DA is nothing but is equal. Now, I will write that side which I know, BD. Now, BD I do not know, so I will not touch it. AD, let me check. AD. AD, again I know that is 10. Divided by DC, which again I know that is. AB is nothing but 25 by 2. Right, just substitute it and you will get the answer. The answer for this question is 41. Alright, on to the next one. Now he says two alloy samples with masses 20 kg and 70 kg. He's talking about the two alloy samples. One 20 and other is 30. Now it contains different percent of copper. Right? I do not know how much percentage each has. So let me consider here to be A% copper and here B% copper. Right? Okay. Now he says two pieces of equal masses were cut from each of the alloy samples. That means from here and from here, equal masses pieces have been cut. Right? But I don't know that mass. So let that mass be x kg. Suppose I have cut x kg from here. Right, and I have cut x kg from here. Right, now I have cut them. Now he says, then fuse together with the remainder of the other samples. Right, so that means I have taken this cut part. I have fused this with the remainder of the other samples. Right, so I have fused this with the remainder of the other samples. Right, so this part actually went with the remainder of this one. Right. Now he says the copper content of the two new alloys then turn out to be the same. Right. Then I have fused this with the remainder of this and I have fused this with the remainder of this. Then the copper content, they are equal. Right. Now he says write the sum of the masses of each of the two pieces that were cut. Right. Now this was x kg, this was x kg. Now he says sum of the masses, so that means x plus x. I need to find. Or basically I need to find x. Right? Now, the big condition here is the copper content of the two new alloys remain the same. So, if I can write the copper content in the first alloy, copper content in the second alloy, I can equate the two. Now, copper content. Mind it, I have taken this copper, right, whatever copper content is over here, this and mixed with this one. Right? So, I have put x kg here, over here, right? Now, here copper percentage was A%. Now, in x kg, how much percent of copper is there? A%. So, how much copper content is there? That is A% of x. Right? This copper, right? I am just talking about copper content now. From the remaining part of this sample, I need my copper. Now, remaining part. Obviously, I have taken x. So, that means my remaining part is 30 minus x. Right? And the copper percentage is B%. Now, the copper content is nothing but B% of the remaining one, which is 30 minus x. Right? Copper content from this piece, copper content from the remaining piece. Obviously, I have fused them together. So, in total, my copper content is much. Right? Now, this is my copper content. Now, he says in percent. It's okay. Right? Copper content I need to divide this by the total amount of the mass. Total mass basically. Total mass is what? Now, mind it, here x kg, here 30 minus x kg. In total, how much? 30. Right? Copper content, total mass. Now, percent put into 100. Right? This is the copper content in percentage of the first alloy. Now, second, similarly we can write that. Now, a copper content in this piece first of all. So, x kg piece, B% copper content. So, in total, B% of x. This is the copper content. Now, this copper content has been fused, the copper from 10 from here, that I can easily figure it out. Remaining is 20 minus X and A% of copper percentage is there. So that means A% of 20 minus X. Right? I have fused them together, so I am adding this. Now, this is copper content. I need to talk about copper content in percentage. So divide by total amount. Right? So X from here, 20 minus X from here. So in total, 20. Right? Percentage, so into 100. So I'll write it here. But I don't need to write it because this 100 and that 100 will get cancelled out anyway. Right? Done. In short, I need to solve this equation. Right? And find the value of X. First of all, obviously 0 and 0 gets cancelled. Then I can cross multiply, I can write this as 2 into, now A% of X, so basically A by 100 of X plus B by 100 of 30 minus X is equal to, now this gets multiplied, 3 into B by 100 of X plus A% of 20 minus X. Obviously, I can take 100 common out, I can take 100 common out, cancel out. In short, at the end, I will have this equation, which will be X into A minus B, that is equal to 12 into A minus B. Right? Now, A minus B, let's see whether it can be 0 or not. He says different percentage of copper. Right? That means A and B are different. That means A minus B cannot be 0. So I can cancel this out. Right? X will turn out to be 12, but I don't want X, I want 2X. 2X will turn out to be 24, which is the answer for this question. Alright, the next one. Now he says a 3-digit number ABC is called virtual prime. 3-digit number ABC is a virtual prime when if one obtains a 2-digit prime number by changing at most one of its units or 10th digits B and C. Right? Okay. So I don't understand this, but he has given us an example. He says 318 is a virtual prime because 17 is prime. Okay. Let me just analyze this. Now 318. Obviously this is a 3-digit number. Now he says it is a virtual prime. That means I can obtain a 2-digit prime number. 2-digit prime number. So maybe I can have 11, maybe I can have 23, maybe I can have 73 and so on. Right? By changing at most one of its units or 10th digits B and C. So, unit is 8, obviously 10 is 1. Right? By changing at most one of these. At most. Right? So, either I can change none of these or I can change one of these. Right? Not both. Because he says at most one. Right? Okay. So, now 1, 8. Now, if I need to change one digit, which digit? He says you can change 8 to 7. Right? 1 has. And we know that 17 is a prime number. If that is the case, that means such kind of number will be called a virtual prime. Right? Okay. Now he says that alpha be the number of such virtual primes. You need to find the value of alpha by 81. So basically I need to find alpha. Right? Okay. So basically I need to have 3-digit number. Now, 3-digit number. Mind that there is no restriction on the first digit, right? We do not care about the first digit at all, right? So maybe I can put in 0. Careful. It's a 3-digit number. Obviously, I cannot put in 0. That means either I can put in 1, 2, 3, 4, so on till 9. Right? I have 9 possibilities for the first one. Right? So I can fill the first place in 9. Right? Now, corresponding to this, I need to decide this. Now, this is the tricky part. Now he says you should have a 2-digit prime number by changing at most one of its unit or 10th digit. Right? I should get a 2-digit prime number. My 2-digit prime numbers look like, let's start with 11. Right? I have 11, I have 13, I have 17, I have 19 and so on. Mind it, 11, 13, 17, 19. Suppose I take the number 10. Right? That's the least 2-digit number that I can think of. Right? Now, if I am taking 10, maybe I can change 0 to 1. If I change 0 to 1, I'll get the number 11, which is the prime number. That means I need to consider the number 10. Right? What about number 11? The next 2-digit number, 11. I can take that. It itself is a prime. I don't need to change anything. Right? Next is 12. Find it. Obviously 12 is not a prime number, but I can change 2 to 3 maybe, or maybe 1, whatever you like it, right? If I change this number to 3, this becomes 13, which is a prime number. That means I will take 12. Obviously I'll take 13. Again, 14 again, because I can change 4 to 1, 3, 9, whatever you like it, right? So I'll take 14. I'll take 15. I'll take 16, 17, 18, 19. So 10 to 19, all of these 2 digits came. Okay, let me think about the 20 is like that. Now, prime number 20, that is 23, then we have 29. Right? Let's start with, suppose we have moved on to 20 now. Now, let's talk about 20. If I replace 0 with 3, I'll get 23. Right? So, I'm getting a 2-digit prime number, so that means I'll take 20. 21. If I replace 1 with 3, again I'll get 23. That means if I take any number from 20 to 29, I can get either, I can make this or this. Right? Done? Now, let's talk about the next prime number, which is 31. And then we have 37. Right? So, again, I will cover up all the numbers from 30 to 39. Right? Similarly, I will cover all of the numbers from 40 to 49. Why? Because I can change one of the digits and I will get 41. Similarly, 50 to 59, 60 to 69, all of the 2-digit numbers are covered up. You take any 2 digits, you just need to change one of its digits and you'll get a prime number. Why? Because in all the 10s from 11 to 20, right, you have a prime number. From 21 to 29, you have a prime number. From 30 to 39, you have a prime number. Right? So in chunks of 10, you have a prime number anyways. So that means any 2-digit number you take, you will get a virtual prime. How many 2 digits are there? 2-digit numbers? From 10 to 99. How many 2-digit numbers are there? 90. Right? So that means I can have 90 possibilities for both of these cases. Right? 90 possibilities. Now, obviously, since I know corresponding to each choice over here I have 90, here I have 9 choices. So in total, I had 9 into 93 choices, which is nothing but 810. This is the number of virtual primes. That is alpha. But I don't want alpha. I want alpha by 81. So divide by 81. Right? The answer is obviously in this case 10. Alright. On to the next one. Now he says if 1 plus tan 1 degree into 1 plus tan 2 into 1 plus tan 3 into so on into 1 plus tan 45 into 1 plus tan 43 into 1 plus tan 44. That is 2 raised to n. And you need to find the value of it. Right? So basically I need to find out this product. Right? Now clearly I can see that these are 44 quantities. I just need to multiply them and get the answer. One way is you can just open it up. But obviously I will not open it like this. I will get lots of terms. Right? So what else can I observe over here? Now mind that my numbers are like this. 1, 2, 3. So on there's 42, 43, 44. 44. 44 degree angle. Do we like 44 degree angle? No. We like 45 degree angle, right? Because we know that tan 45 degree is a very nice number, which is 1. 44 is there. 45 is not there. Okay. But then 43 is there. 43 is there. Very near to 45. Cool. 42 is there. Very near to 45. 44 is there. I need 45. That means if only I had 1 degree more. Wait a second. In my product, I have 44 degrees and I have 1 degree. Now, I don't think that can be a coincidence. What will happen? Let's see. I like 1 degree and I like 44 degree because if I combine the two, I have 45 degree. So let me see what happens when I combine these two terms. Right? Even if I want to multiply, I'll take 2 terms and multiply it. Obviously, I will not take the first 2. That will be too obvious anyway. So I take first and last one. Let's see what happens. So I'll multiply 1 plus tan 1 degree into 1 plus tan 44 degree. Right? This is nothing but 1 plus tan 1 degree plus tan 44 degree plus tan 1 degree into tan 44 degree. Now, some of the things we have already studied. Tan 1 plus tan 44. Then product of these two quantities. In which formula have I studied this one? Tan of A plus B. Anyways, I want 1 plus 44, then only I'll get 45, which is a nice angle, right? So let me just write 1 plus 44 as 45. Taking tangent of both the sides, I will get tan of 1 plus 44 is equal to tan 45. Obviously, I'm talking about the angles in degree over here. I might skip it because we are talking about degree now, right? So tan of A plus B is nothing but tan A plus tan B whole divided by 1 minus tan A into tan is equal to, now tan 45 is already 1. Cross multiply. Let's see what happens. So tan 1 plus tan 44 is equal to 1 minus tan 1 into tan 44. Wait a second. Tan 1 plus tan 44, I want plus, right? Shift this to this side. Let's see what happens. So this is plus tan 1 into tan 44. This is equal to 1, right? So that means value of this quantity will turn out to be 1. Value of this quantity is nothing but 1. So 1 plus 1, that is 2. Very nice number. If I multiply first and last, the number is very nice, which is 2. Let's see what happens when I multiply second and second last. That means 1 plus tan 2 degree into 1 plus tan 43. Right? Again, I'll get 1 plus tan 2 degree plus tan 45 degree, 43 degree plus tan 2 into tan 43. Again, I know that 2 plus 43 is a very nice number, which is, I'll just change it. 2 plus 43. So, 2, 43. Same thing I will do, and again, ultimately I'll get tan 2 plus tan 43 plus tan 2 into tan 43. That will turn out to be 1. Right? Again, this quantity is 1. 1 plus 1, 2. Right? Now I think we can see the pattern. First and last product is 2. Second last product is 2 again. Third last product is 2 again. That means when I pair it up, the product turns out to be 2. Now the question is, how many 2's are there? The number of 2 will be dependent on number of pairs, right? How many pairs? Now I know in total 44 terms are there. How many pairs will it be? 22 pairs. So that means it will be 2 into 2 into so on into 2. How many times? 22 times. So that means 2 is for 22. The product of this quantity is nothing but 2 is for 22, which he says is equal to 2 raised to n. Which is obvious that n is actually equal to 22, which is the correct answer for this question. Alright, on to the next one. He says the following 4 operations were performed on 2 positive integers. Right? So let me take those positive integers as x and y. Right? Now, he says they were added, so that means it becomes x plus y. Then he says the second operation was the lesser was subtracted from the greater. Right? So obviously I do not know which is the greater or the lesser one. So arbitrarily I can say that x is the greater one. So the lesser was subtracted from the greater, so that means I am talking about x minus y. Right? They were multiplied together, so that means I am talking about x y. And the larger number was divided by the smaller one, so that is x divided by y. Right? So in each these cases I got these 4 results. He says the results thus obtained were then combined to form a sum of 243. Now these 4 were combined to have the sum of 243. That means this plus this plus this plus this, that is 243. That is 243. Right? Now he says write the sum of 2 positive integers if each is greater than 5. So basically I need to find the values of x and y. Let's see. So I have this equation. So obviously this gets cancelled, I'll get 2x plus xy plus x by y, that is 240. Next step I take LCM and I'll cross multiply y, so I'll get 2xy plus xy square plus x equal to 243y. Right? Now the thing is, how should I proceed further? I have just one equation and I need to find the value of x and y. Mind it, x and y are integers. So that means somehow some factorization should be there, right? Now I can say x is here, x is here, x is here. Let me take x common. Let's see what happens. X common. I'll be left with 2y plus y square plus 1. Wait a second. I'm left with 2y plus y square plus 1. This is a very nice term. Okay, let me rearrange it. Let me write y square plus 2y plus 1. A very nice sum. This is nothing but y plus 1 whole square. Right? So left hand side is nothing but x into y plus 1 whole square is equal to 243y. Right? Mind it. Now y will definitely not divide y plus 1 square. Right? Y will divide x. That much I know. So the remaining thing, 243 must divide this one. Right? 243 must divide this one. Mind it, this is y plus 1 whole square. This is a perfect square. 243 is what? 3 raised to 5, right? 3 raised to 5. Now, if this must divide this, what are the possibilities over here? 3 raised to 5 must divide this. So either, since it's a perfect square, maybe it is 3 raised to 2. Maybe it is 3 raised to 4. Right? Now, this must divide this, so either this is the case or this is the case. So let me take both of these cases. Then y plus 1 whole square is equal to 3 square. From here, I'll get y plus 1 is equal to 3 here, and I'll get y is equal to 2. Mind it, he says if each is greater than 5, that means this is greater than 5 and this is greater than 5. Y should be greater than 5 as well. Y is just 2, which is obviously less than 5, so reject it. Second case, y plus 1 whole square, that is equal to 3 raised to 4. From here, I can find that y is nothing but 8. Now, which is greater than 5. Now, if y is 8, I can get the corresponding value of x. X will turn out to be 24. Right? So, he says write the sum of two positive integers. First integer, that is 24. Second integer is 8. I want the sum. That means the answer for this question is 32. Alright, on to the next one. Now, he says write the number of ordered pairs x, y, where x and y are natural numbers, such that their HCF and LCM is 322, such that the sum of HCF and LCM is 322. Right? Now, I need to find the number of ordered pairs. So, I need to find the numbers basically. I need to find x and y. Now, he says sum of their HCF and LCM should be 322. Now, I don't know the HCF, right? Nothing is given in the question about their HCF. So, let the HCF of these two numbers be 8. Right? Good. Now, highest common factor is 8. Now, A must be present in X and A must be present in Y. Right? Along with A, I might have something else. Along with A over here, I might have something else. Okay? Now, that something else, maybe that is C. And this something else, that is Q. Mind it, since HCF is A, that means highest common factor, that is A. P and Q should not have any other common prime factor. Now, if P and Q have no common prime factor, that means these two, P and Q, are co-prime to each other. Right? Now, sum of their HCF. HCF I know, that is A. We have taken that to be A. Now, LCM. Now, mind it, A is present over here, A is present over here. In LCM, A must be present. A is present. Right? Now, P is present over here. And P is obviously not present over here. That means this entirety has to come in the lowest common multiple. Because it has to be a multiple of this, it has to be a multiple of this. Now, if it is a multiple of this, that means P has to be there. Similarly, Q has to be there because I'm talking about the multiple of this one. So, Q has to be there. Right? This is the least that I have to do in order to get the common multiple. That is why the LCM is APQ. Right? Now, he says sum. So, that means A plus APQ. This turns out to be 322. Right? Obviously, A is common. I get A into 1 plus PQ. That is equal to 322. Right? I need to solve this equation. Mind it, I have a big condition. Why? X and Y are natural numbers. That means A has to be a natural number. That means B has to be a natural number. Q has to be a natural number. I need to solve this equation over the collection of natural numbers. My equation is A into 1 plus PQ. That is equal to 322. This is a natural number. This is a natural number. Product of two natural numbers is 322. I can write 322 as product of two natural numbers. That's not a big deal. Right? So, first case I can take, that is 1 into 322. Right? Second case, that is 2 into 161. Then 7 into 46. Then 14 into 23. 23 into 41, 23 into 14, of course, right? And 46 into 7, 161 into 2, 322 into 1. Hardly some cases are there. Let me see what is happening in the first case. Now, in the first case, I have A is equal to 1, absolutely fine. Then 1 plus PQ, that is equal to 320. That means PQ is nothing but 321. Again, this is a natural number, this is a natural number. Product of two natural numbers is 321. Hardly any cases. In fact, I will get just 4 cases. 1, 321, 3, 107, then 107, 3, 321, 1. Right? Since I'm talking about the ordered pairs, ordering matters over here. Right? So that is why I take all of these. From here, I'm getting 4. Right? So, when P is equal to 1, Q is equal to 321, I know that A is equal to 1. One ordered pair I'll get. I can see because one ordered pair is 1 into 1, AP. Right? Second number is A into Q, so 1 into 321. First ordered pair. Right? From here, I got one ordered pair. Second, A into P, so that is 1 into 3. Second number is A into Q, so that is 107, 1 into 107. Second order pair, so second order pair. Similarly, I get third order pair, then fourth. That means from these 4, I am getting 4 order pairs. So I will write 4 order pairs. Let's see in the second case. Right, this case is done. Second is A is 2. Then 1 plus PQ is equal to 161. So PQ in turns out to be 160. Right, natural numbers, product of two natural numbers, 160. Now, I will have cases like 1, 160, then I have 2, 80. Now, careful. 2 and 80. P, 2, Q, 80. Mind it, I said that P and Q are co-primes. Right? Because if they do have a common prime factor, my HCs will change. Now, 2 and 80 obviously have a common prime factor, which is 2. So that means this cannot be the case. Rejected. Second, I have 4 and 40. Again, common prime factor is there, so rejected. Then I have 5 and 32. No common prime factor, I'll take it. Next is 8 into 20. Common prime factor is there. 10, 16, common prime factor, and so on. Next, I'll get 32 and 5. Then, obviously, I'll get 160 and 1. Right? From this, I'll get one order pair, second order pair, third, fourth. So, again, I'll get 4 more. Right? In similar lines, you can exhaust from this one. You will get 4 order pairs from here. You will get, okay, 4 is, A is equal to 46. Yeah, 4 from here, 4 from here, okay, 4 from here, and 1 from here, and 0 from here. Right? On similar lines, you can exhaust it. And he says total number of ordered pairs, if you add these up, the answer for this question will turn out to be 20. Alright, for the next question, he says consider this equation where R is real. Now he says this equation has 2 distinct solutions. Now a quadratic equation has 2 distinct solutions which are both negative. Right? So distinct solutions I have, and both of them are negative. So negative, negative. Exactly when P is less than R, less than Q. So that means there is a restriction on R basically. Right? For some real numbers P and Q, you need to write the value of Q minus P. Right? So basically Q minus P, you need the restriction on R. Right? So you need to find where R is very strong. From which value to which value. Now 2 conditions are given to you. First is, it has distinct solutions. Right? A quadratic equation has distinct solutions. That means discriminant needs to be greater than 0. Right? Okay. So discriminant is greater than 0. So let me write my discriminant. C square minus 4ac. So R plus 7 whole square minus 4 into A is obviously 1 into C, which is obviously R plus 8. He says this is greater than 0. Right? This will actually turn out to be quadratic, which you can factorize. It turns out to be R plus 23 into R minus 30 greater than 0. Right? That means R is either greater than 30 or R is less than minus 20. Either this is the case or this is the case. First condition done. Now, let me utilize the second condition. Second condition is both the roots are negative. Both the roots are negative. That means what can I say about coefficients, because R is involved in the coefficients? What can I say about the coefficients of the equation? Mind it, if both the roots are negative, that means sum will be negative. Right? Now, sum of roots you can have using the coefficients. Also, if both the roots are negative, that means product has to be positive. Right? Now, first of all, sum is negative. Sum is nothing but R plus 7. R plus 7 is negative, that means less than 0. Right? And at the same time, he says product is positive. Product is nothing but R plus 87. Positive greater than 0. Right? From here, I can say R is less than minus 7 and R is greater than minus 87. Right? That means if I combine the two, I can say that R lies between minus 87 and minus 7. Second condition. Right? Both of these conditions have to be satisfied. Now, if both of them have to be satisfied, maybe I can have the number line, or if I can see the answer straight away, good for you. But I'll make the number line. Right? So I will mark minus 87, then I'll mark minus 23, then minus 7, then 13. Right? Now, first is R is less than minus 23. So either R is in this one. Less than, so obviously there's a whole over here. And R greater than 13. All real numbers go greater than 13. Right? First condition. Second, minus 87 to minus 7. So here. So here. Right? Now, I want R to satisfy this as well as this. So that means R should lie over here and it should lie over here. So that means the common part. So that means I'm talking about this one. Right? No common part, no common part. So this is the only common part. So that means R must vary from minus 87 and minus 26. Right? Done. Now, my P and Q are fixed. My P is minus 87. My Q is minus 23. Just substitute it and you will get the answer as 64. Alright, on to the next one. Now he says write the area of a right angle triangle. If it is known that the radius of inscribed circle is 3 and that of the circumscribed circle is 8. So I need to talk about a right angle triangle. Right? So let that be this one. Right? He is talking about the inscribed circle as well as the circumscribed. So let me have my inscribed circle first. Inscribed as in touching all the sides. Circumscribed passing through all the vertices. Cool. I mean, this is a circle. Okay. Nice. Pretty. So my triangle is ABC, obviously, and this is 90 because he says so. Also, now, he says radius of the inscribed circle. So that means radius of the circle is 3. So, maybe I have the center and this distance that is given to us 3. Right? Okay. So, now he says and that of the circumscribed circle is 8. So, radius of the what? The circumscribed one, that is 8. Mind it, radius. First of all, let me talk about the center of the circumscribed circle. Mind it, this is a right triangle, right? So that means this is a semicircle because angle in a semicircle is 90 degrees. So AC is the diameter. That means center of AC would be the center. Center of the AC would be the center of the circle. Right? And he says radius, so that means this much is 8. Right? He says we need to find the area. Now, area of the triangle I can find out if I know BC and I know AB. Because half into BC into AB, base into height. Right? Okay. What else do I know? Now the thing is, I know that this is 3. I know that this is 3. If I join these two. Right? This is 90, this is 90. Wait a second, it's square over here. Right? Now, this is 3, that means this is 3. That means this is. So let me name this as D. This be E, this be F. I do not know BC, but at least I know a certain part of it. Right? If I can find out this part, maybe my problem will be solved, or maybe I'll proceed further. Now, I need to find this one. Mind it that C is the point outside the smaller circle. That means CD is the tangent. CD is the tangent and CE is the tangent. Right? If I want to know this, I should know CE. I don't know CE, I know CO, which is 8. CE. I don't know this part. It's okay. I don't know this part, let that be x. Fine. Right? So this is 8 plus x, so that means this is 8 plus x. Interesting. Now, mind it again, this is the radius from O to A, this is 8, this is x. That means this tiny portion is nothing but 8 minus x. This is 8 minus x. Mind it, A is the point outside the circle, so the smaller one. This is the tangent, this is the tangent. If this is 8 minus x, this is 8 minus x. Right? And f to b, that was, okay, my diagram is not that pretty. Basically, it was this one. This is 90, right? This was nothing but 3. I think my question is solved. See, if I need to find the area of the triangle, all I need to do is find the value of x. That means I need to set up an equation. Now, what part have I not utilized properly? This 90 degrees. 90 degrees, that means Pythagoras theorem. That means this square plus this square is equal to this square. Now, this is how much? This is 8 minus x, this is 3. So, entirety is 11 minus x. Now, BC square, that means this plus this, that means 11 plus x whole square. That is equal to the entire thing. Obviously, the entire thing would be 16. Right? From here, you can find the value of x. X turns out to be root 7. Right? Root 7. Now, I need to find the area. So, half. BC is nothing but 3 plus 8 plus 7. So, that means 11 plus root x. And that is 11 minus root x. Right? You can find out the value and the answer will turn out to be 57. Alright. On to the next one. Now you say sequence A0, A1, A2, so on. It's such that for all non-negative integers, m and n, both of them non-negative, that means m can be 0, 1, 2, 3, so on, and n can be 0, 1, 2, 3, and so on. And m is greater than or equal to 1. Right? We have this relationship. Now he says that A1 is equal to 1. You need to find A7. Right? Now, mind it, A7 is nothing but 8th term of the sequence. If we can find out the first 7 terms, 8 to nikal hi lungi. Right? Not a big deal. So, let me find out the first term of the sequence, which is A0. Mind it, it is A0. Let's see whether I can find it or not. Right? If I need to find out A0, A1 is given to me, that is 1. Now, I need to find A0. How should I proceed? What I can do is, I can put M as 1. Let me start. Let me take M as something. So, let me take M as 1. Right? Now, 1 should be greater than equal to N. That is absolutely fine. N, let me figure out. Now the least value of n that I can take, that is 0. Let's see what happens. Right? If this is the case, this relation actually turns out to be A, m plus n, so that is 1, plus A, m minus n, so that is 1 plus 0, which is 1, is equal to A, 2m, which is A2, plus A naught, whole divided by 2. Right? Now, this does not help me provided I do not know, provided I do not know A0. Now, instead of starting with this, what I can do is, I can have m as 0 and n as 0. Let me start with that. Let's see what happens. Right? Now, obviously m plus n, that is 0, so A0 plus A0 is equal to A0 plus A0 whole divided by 2. Right? So this actually becomes 2A0 is equal to A0. So A0 turns out to be 0. Done? Right? So A0 turns out to be 0. So A1 I already know and A0 I just found out. Now, when I applied this, I got A0. Now, let me go back to my previous one. So, second thing I can use m is equal to 1, n is equal to 0. This turned out to be equal to, just substitute it here, I'll get A1 plus A1 is equal to A2 plus A0 whole divided by, right? Just substitute and this one. Now I know A1, I know A0, I just need to find out A2. So A2 will turn out to be, right? Now this is a very nice thing. I know A0, I know A1, I know A2, right? My sequence is proceeding further. Let me see whether I can have A3 or not. Let's see. What else can I do? next thing, if I want A3, I should have M as 2 and N as 1. But for that, this will become A3, but this will become A4. So instead of finding out A3 first, let me have A4 first. Right? So I can put M as 2 and N as 0. Let's see what happens. So substitute it here. This becomes A2 plus A2 is equal to A4 plus A0 whole divided by 2. From here I know A4 that will turn out to be 16. Interesting. Right? Now I will try to find out A3. A3 I'll go because I will want 2 plus 1. So put M as 2 and N as 1. So that becomes A3 plus A1 is equal to A4 plus A2 whole divided by 2. Right? I know A1, I know A4, I know A2. I can find A3. A3 will turn out to be. Right? Now, instead I know A3, A4. Instead of finding A5 first, I'll find A6. Then I'll find A5. Then I'll find A8. Then I'll find A7. Right? Using these things again and again and again, I will get my A7, which will turn out to be 49. This is a very nice number. Why? A0 is 0, A1 is 1, A2 is 4, A3 is 9, A4 is 16, A5 turns out to be 25, and A6 36, and A7 49. Interesting. Alright, on to the next one. Now he says if n is the number of positive integers less than 1000 that contain at least one 1, right? At least one should be there. At least one 1 should be there. So that means I can have maybe just 1 1. Maybe I can have 2 1, right? Then I can have 3 1. Do you think I can have 4 1? No. I want less than 1000. So either I have a 1-digit number or a 2-digit number or a 3-digit number, right? Now, in their decimal representation, then write the value of zint of n by 4, where obviously zint of x is the greatest integer less than or equal to n. Right? Fine. This I'll figure out later on. First of all, I am interested in the value of n. Right? N is the number of positive integers less than 1000 which contain at least one 1. Right? Now, the thing is, I need to consider this case when it has exactly 1. Right? When it has exactly 2 and when it has exactly 3. Right? I have 3 different cases. Mind it, there is just one case left. Since all I am interested in 1-digit number or 2-digit number or 3-digit number, only one case is there which is left, which is when ones are not there, when there is no ones in the decimal expansion, in the decimal representation. Right? Now, don't you think this is much easier to find out? If I can find out this, right, I'll subtract this from the entire numbers. Now, he says numbers less than 1000, so that means I am considering the numbers from what? 1, 2, so on to 999. How many numbers are there? 990. From this, if I subtract these numbers, I will satisfy the condition. Now, he says 1 should not be there. Now, first of all, let me consider the 1-digit number. 1, right? So maybe I can 0, obviously not. 1, obviously not. 2, 3, so on till 9. So that means I will have 8 numbers, right? 2-digit number. Not right. 2-digit number. Mind it, 1 should not be there. Now, first place, obviously I cannot put in 0 over here or 1 over here. That means I can fill this place in 8 different. Corresponding to this, in how many ways can I fill this one? I cannot put 1 now. Right? Except for 1, I can have maybe 0, I can have 2, I can have 5. So that means I have 9 possibilities. Right? Now, corresponding to each choice over here, 9 choices were there. Right? Now, it has 8 choices. That means in total, I have 8 into 9. Which is, you can find out which is 70. Right? Now, third case, 3-digit number. 1 should not be present. Now, first case, 0 cannot be there, 1 should not be there. So that means 8 ways. Corresponding to this, 1 cannot be there, that means 9 ways. Corresponding to this, 1 should not be there, 9 ways. In total, it should be 8 into 9 into 9. which actually turns out to be 648. Right? So these, how many these are numbers? These are in total 728 in number. These are the numbers that I do not want. If I don't want these numbers, I can subtract it from my 999. Right? This will turn out to be 271. That means in total 271 positive integers are there less than 1000 which contain at least 1. Right? That means n turns out to be 7. But I don't want n. I want n by 4. First of all, n by 4. So that means 271 by 4, that is 67 point something. Right? Now he says I need to find out the greatest integer less than or equal to x. Now this is 67 point something, less than integer source term. 67, then I have 66, then I have 65 and so on. Right? It is greatest among these, which is 67. That is why the answer for this question is 67. Alright, on to the next one. Now he says A, B, C, D be distinct real numbers such that A and B are roots of this equation, C and D are roots of this equation. You need to find the value of B plus C by x. Right? So maybe I can find B and D individually, or maybe I can have B plus D. Right. Now let me use this. He says A and B are roots of this equation. So x square minus 7cx minus 8b equals 0. Right? Now I know that A and B are the roots. Right? The second equation is x square minus 7ax minus 8b equals 0. And my roots are C and C. Right? I am interested in the expression B plus C basically. Right? B plus C. That is an adding series. Now I know that A plus B, as in sum of the roots, A plus B, that will turn out to be 7c. Right? And AB, let me write it whether I use it or not, I do not know. AB is minus 8b. Similarly, I can say that C plus D, that is equal to 7a. And CD is equal to minus 8b. Right? I want B plus D. B plus D. So I can take this equation and this equation. I can add them up. I will at least get B plus D. Now, if I add these two, I will actually get B plus D is actually equal to 6 into C plus D. We are equal. Right? Now, if I want to find B plus D, now I need to find C. Somehow I need to find the value of this one. Right? A plus D. Now, thing is, I've already utilized this one. What else can I do? Now, what else can I do? Now, the thing is, question is tough. I have utilized the relationship between roots and coefficients. Done. And I have arrived this condition. But the thing is, if I need to find the value of this, I need the value of this. And my question is tough. What else? See, it is given to me that A and B are the roots of the equation, right? One way is using the relationship. Other way is what? If A and B are roots of the equation, what else can I say? Let me say. Now, A is the root of the equation. That means A will satisfy this equation. If I replace x by A, left hand side should be equal to 0. So, this is nothing but A square minus 7c minus 8b equal to 0. Okay. Let me just write it. And we also know that B is the 0. So that means it should satisfy B square minus 7bc minus 8d equal to 0. Right? Let's see. Maybe I can use it or not. Let me write for this thing also. Now C is the root. So that means C square minus 7ac, okay, minus 8d equal to 0. Wait a second. AC. Maybe. Let's see what happens. Let me put D also. So D square minus 7AD minus 8 equal to 0. These two conditions. Now, just look at this and this. Which two equations should you pick up in order to have another condition? Right? Obviously. In दोनों को साथ तो नहीं करूँगे तो same thing का. One equation I take from here, one equation I take from here. Then only I talk about some conditions, right? Because I need to relate B and D. Or A and C. One from here, one from here. Now mind it, AC is. Let me use these two conditions. Let's see what happens. So A square minus 7AC minus AD equal to 0. And the second thing is c square minus 7ac minus 8b equal to 0. Right? Now, so testing. Subtract it. Let's see what happens. So, a square minus c square actually will turn out to be minus d into b minus c. Or you can adjust minus, doesn't matter. Cool. Now, a plus c value चाहिए मेरे पास a square minus c square आ गया. A square minus c square. In a square minus c square, obviously I have this a plus c. So let me factor it. A plus c into a minus c is equal to minus 8 into d minus c. The problem doesn't solve. I wanted a plus c. Now a plus c has a minus c and b minus d along with it. Interesting. Wait a second. A minus c and b minus d. A minus c, b minus d might come from these two relations again. Let me rewrite them. A plus b is equal to 7c and c plus d is equal to 7. Right? I want a minus c, subtract the 2. So I'll get a, subtract. So I will get b minus d equal to 8c, 8 into c minus c. Just check it out. Right? This relation I have. Now wait a second. B minus D is there in terms of C minus A. Or A minus C है उसको ठीक करके लिख लेते हैं. B minus D is equal to minus 8 into A minus C. Abhi? Now here if I substitute the value of B minus D, A minus C will come into the picture and hopefully cancel out. Let's see what happens. A plus C into A minus C. I will not touch it. Minus 8 into. Substitute the value of B minus D, which is minus 8 into A minus C. Right? Minus 8, this becomes 64. Also, A minus C, A minus C. I know that A and C are distinct. Cancel out, doesn't matter. Right? So that means A plus C is 64. Right? I got the value of A plus C. Now, substitute it here. B plus D चाहिए, B plus D is nothing but 6 into 64. Right? B plus D I got, but that is 6 into 64. I need to divide it by 8. So obviously the answer will turn out to be 48. Which is the correct one for this question. Right? So this was part 1 of the video for 13 to 20th or 22 actually. We'll see. For the next set of questions, please watch part 2 of the video.